Yeah. I don't care. It's working.
We can try fixing the break
Yeah,
if we
it's
really
working. That's right. All right. Good morning, everyone. I thought we'd start with what does everyone remember from last week? Because quite a few of you felt it was going a little bit too fast and you wanted it a little bit slowed down today. So let's see what we can do for that. Hope everyone had a good weekend. And then we'll start in about 1 minute. All right, let's get this party started. This is the one that we missed out last time. Thought I'd give away the answer in the question. It's... Who do you want to hear, me or the... It's not coming through. It's the wrong feed. Oh. All right. Just remember that the main function in C is the main function. So it's int main and then whatever happens in the brackets. And it's the point... Well, no, because I think the next question asks what's the point of it. All right, we've got a lead. Yes, why do we have a main function? Oh, very good. Yes, the main function provides us with a known entry point, so we know where to start the execution. Oh. What do you do if none of them are correct? Choose the closest one that would potentially be correct because none of those are correct. I thought I'd trick you all. False sense of security. Yep. Can someone tell me what's the mistake in that? That's the close. Yep. Yes, it should be double quotation marks. Definitely not those single quotation marks. Very good. That wasn't you, Sophia. That wasn't you. All right, next one. Oh, that hurts. Yeah, it is always the question, which way should the slash go? And whoever was the red, that's the wrong way. All right. Not bad. Not bad. All right, so remember we do hash include and then greater than, less than symbols, which you will find out today I have a big issue with. I keep getting them the wrong way around. Excellent. Really seeing where everyone's at. What can you all remember from the first week? All right, so I put that one in really just to say you can compile any number of ways as long as after this -o, what follows is the name of the file without the extension. You can't do it any other way. And you don't have to have that -o and whatever the name of the file is as well that you're producing. Okay. Oh, we've got someone different coming out on top now. Just throwing you with those backslashes again. Which way does it go? Oh, a few people got the wrong. Okay, so you will never execute a .c extension file. .c is the file that a human can read and that you've written, but what you execute is the executable file, which means you don't need the .c extension. You will execute the file that you have used the compiler to make, so it's translated into something that a computer can understand. All right, let's see who's come out on top. And let's see who's... Oh no, there's one more question. Oh, I'm just too excited. This is also the wrong Kahoot. I did update it last night. Oh, very nice. Yeah, a bit of standard, nothing much. Here we go. Who's on the podium? Yep, let's get ready to throw Casper, the friendly ghost. Big eyes, small face, interesting name. And in top place. Yes. Was that the top place? Did you just smack in the face for the top place? Were you traumatized? All right. I should probably switch off the music on that. Nope, that's not what nope. There we go. All right. So, looked okay. It looked like everyone was kind of coping. There was a bit of feedback that I will take on board, as well as splitting up my files today. So we'll have quite a few files going for every new topic that we cover, so that when you come back to it, you'll be able to know where to go and what to do. So today, well, last week we did a whole bunch of beginning stuff. We lulled you into a nice secure place. This is going to be great. This course is going to be great. And today we start to kill that a little bit. So last week we did printf and scanf. It was a way to put stuff out to terminal and read stuff from terminal. We're going to talk a little bit more about scanf today. And then we'll continue using our printf. And then we're going to do variables. Oh, that's so annoying. That Kahoot was missing my beautiful variable questions. It had some nice calculations. Maybe we can do that later if we have time. So today we're going to start to look at if statements, which is a way that we can actually put some logic into our programs and kind of decide which parts of our code to run and which ones not to run. We're going to look at logical operators, and then we're going to hopefully look at loops. If we don't get to loops today, if I need to slow down, then we're going to do loops on Wednesday, definitely on Wednesday, because we have to get through loops this week as well. But we're definitely doing if statements. And I think Sophia's going to, every 30 minutes, run a poll on YouTube if I'm going too fast, too slow, or just right, just to give me an indication of what on earth I should be doing, because all I ever see is just a whole bunch of nodding faces, and that's not apparently what was happening. It was just empty nods. So very nice. Thank you for that. Live lecture code, not that we've started anything, but I have already made little stubs of files in that week's lecture code so that we're not starting from the very beginning. I don't need to start a file from the very beginning now that we've kind of done a little bit. All right. Who wants a rehash of variables from last week? See? No one. And then in the chat it'll be like everyone. Can you just do a poll so it's anonymous? Thank you. The question is, do we want to rehash the variables file, which I did go wild in. Comment, uncomment, comment, uncomment. What's rehashed? Go over it again. See, the online people are a lot more forthcoming. It'd be funny if they're also sitting in the audience too. Okay. All right. Oh, that's not what I meant to do. I thought I'd do some drawing today as well, so not like that though. At least I don't have to use the keyboard that's here with the sticky T. Okay, can everyone see the font at the back, actually? Yes? And what about the lights? Are the lights annoying? Someone said they couldn't see much because the lights were on the screen. Ooh. Awful. Is that all right? Can you see, Sophia, can you please go to the back and see if you can see the screen and the fonts? How's that? Better? Okay. All right, so let's have a look what we have. Okay, so last week we looked at variables and constants. So why do we need variables? Variables is a way for the computer to store any kind of values that we might want to manipulate through our program. So we kind of need it if we want to do anything interesting at all. Otherwise, we're just kind of hard coding everything and not actually performing any manipulation. So variables are pretty important. Without them, we don't really have much going on. Now, when we use variables in our code, what we need to do is we need to declare what type of variable we're using, and we need to name that variable, and then we need to initialize it. So to declare a variable, you say what type it is, and we did 3 types of variable last week. We did ints, which is an integer value. We did doubles, which is floating point values. or decimals, and then we did chars, which is characters in the ASCII table. So we learned 3, and then we write a name for that variable, whatever name we want. Try to make it descriptive of what on earth that variable is doing, or what value it is storing, because that will help with code readability later on when you have to kind of come back to it. And then we initialize it, and to initialize the variable we use =, and then whatever value we want to assign to it comes on the other side of that =. And you can do it all in one line if you want. You don't have to do it in 2 lines. You can do it like this, where you say the type of variable, then you say variable name, and then equals, so assign value, and then whatever the value is that you want to assign. Okay, so we did our printf statements, and we learned how inside the printf statement we can actually put a variable in. And the reason for that, again, is so that we're not hard coding everything, because there's no way, if a value has changed throughout the program, you would know what it is. You wouldn't be able to output it if you weren't able to put a variable into a printf statement. So there is, to output in the printf statements, we use these format specifiers, and you've learned 3 types. You've got a %d, so that's for an int, a %lf for a decimal point, or that stands for long float, or we've got %c for a character. So once you have a format specifier in there, after your printf statement you'll put a comma and whatever variable you actually want to substitute in for that for that format specifier, so whatever actually goes in there. And then you can have as many as you want, and then just do them in their respective numbers. And then we got up to these hash defines, which are constants in your code. And I noticed that on the forum there was a lot of very good questions about these constants. Someone asked, why do you not have to specify what type the constant is? I haven't had to say anything. I've just given it a name, and the name has to be in capital letters because that's our style guide. And then I've just given it a value, and I've assumed that everything is going to be fine, peachy. So why don't I need to kind of give it a type? And that's because this hash define, kind of what it does is like a find and replace situation. So it will find any occurrences where I've written pi in my code, and it will replace it with the value that I've given. And that will force it into a type, I suppose, because you've defined what it is. And we'll talk more about it as I run through the code. We'll see exactly what it does. Okay, more rehash, less rehash? Right in front of me and I didn't see it, yeah? Very good question. Yeah, so the question for those online is, if you're defining a hash defining a character, would you put quotation marks around it? So you would put the single quotes around it to show that it's, on the ASCII table. I'm struggling with words today. Monday's an awful day. It shouldn't exist in the week. Pardon? Follow-up question. Go on.
You know how main is our main function for the code?
Yeah.
Why is the define sitting outside of it?
Okay, another great question. Okay. So the question is, why is the define sitting outside the main function? And the reason for that is because we want that hash define to be available throughout all of our code, right? The constant. In week 3, which is actually next week, you will learn that it's not just your main. You might have other functions in there. And if you define it outside of your main, it will be available to everything that is in this file. So all other functions, not just, because any variable that we define in here, any variable that we declare, and then we initialize inside our main, those are variables that go on the stack. And what happens is when we exit our function, so when we get to the very end of this function, here this returns 0, and then this bracket close, all of those variables are killed. They are not available anywhere else. And we will talk more about that as well as the weeks go on. But that hash define is still available across all the different functions. Okay, any other questions? Those were excellent questions. Yeah?
Why are we using hash define instead of like a const and a variable, like a type of
Oh, it was coming, this question. I knew it. Okay, so the question is for those online, why do we use a hash define and not a constant? There is a constant definition as well in C. So in 1511, just to put it out there, we do not use global constants, and we don't, because they can be dangerous in your code, right? Because you kind of lose track of them, and then all sorts of issues. Even though you'll see that in 1511, we don't actually write very big programs until you get to assignment 1, assignment 2. Those might expand a little bit, but still there's not so many lines of code that you wouldn't be able to keep track of it. But constants can be dangerous in large chunks of code where you kind of start to lose track where they are hanging outside, and then when you have multiple files as well and you combine them together. So in 1511, we say no to constants and we use hash defines, and that's it. And there's, yeah, basically just stick with that in 1511. So in 1511, we try to keep things a lot more simple, and we try to kind of stop you from running into issues that you will then learn about in further computing courses as well. Okay, Sophia, can you do a poll, please? So I can see if we can move on. The pressure is on. Come on, Sophia. No, sorry. You've got 2 seconds. Go on then. Someone online said, can the value of a constant be modified later? No, that's why it's a constant. We want it to stay constant. It cannot change. It does not change ever. The purpose of a constant is to have, if you have a value in your code that never needs to change, you make it a constant because it's easier to read. Okay. And let me... Okay, how are we doing? Oh, lots of people are doing great. Fantastic. Okay. Oh, everyone's doing great. Good. All right, let's move on then. Fantastic. Great. Okay, decision time. How exciting. Okay, sorry. There's a cupboard that just keeps opening and hitting me every... Sophia, yes. I'm so sorry. Actually, can one of you please go to CSC admin and get sticky tape? Thank you so much. I cannot take that tray opening into me one more time. Okay, so sometimes in our code we have to make decisions, and that seems reasonable. That means that we can have a series of instructions, and depending what's happening in our code, we can branch to those decisions based on what we want the computer to do or what we want our program to do. It means that we're able to kind of control what's going on, and we're able to kind of switch on and switch off statements as we need them. And in C, this is an if statement. So who's heard of if statements before? Yay! If, then, else, basically. Okay, so a decision problem is anywhere that you will have to ask yourself a question with a yes or no answer. If you have a yes or no answer, then that's the perfect time to use an if statement. So is the number even? Yes, I want to do something. No, I want to do something else. You're going to use an if statement in code. Is a number larger than 100? Similar. You're going to use an if statement to check for that, and you might do something if it's yes, and you might do something else if it's no. Or you might also have, you might actually nest it with an else. So you might have a series of things that you're checking for. So first we ask the question, and that's our condition. That goes inside brackets on our if. And if the answer in our condition is yes, then we will run the code that's kind of in here. And I've used 2 keywords. I don't know why. This is just basically a comment, do something and do something else. It's just letting you know that that's going to run to do something. If the answer to the question is no, then we can also add an else statement. And that means that we can let the computer know what code to run. So for example, if I have something, if condition, so if something happens here and it's true, then I will run this part here. Now, if it's false, what's going to happen, if the thing inside these brackets is false, I'm going to skip this part. So this part here only runs if it's true, and then I will go to the else, and I will run this if the condition tested false, then I will run that second condition inside the else. You can keep chaining them together because my answer might be no, and then I might ask something again, and the answer to that is no. And then there's really a limit to how much you can chain before that code becomes absolutely unreadable. But you can chain, a little bit, especially when we haven't learned about anything else. This week you can chain to your heart's content, really. And then you'll learn, that there is a limit to that and how that code becomes unreadable. Oh my God, thank you so much for that. Can you just tape those two together? Thank you.
How do you
Okay,
rip it?
that's great.
It's not ripping.
Thank you.
Do you want me to keep it here in case?
Yes, please. Thank you very much for that. Okay, so that's exciting. But how do we compare something? We'll have to have some sort of relational operators, and they might work with numbers or even characters, because as you remember, characters are actually numbers. They're ASCII numbers, so they've got a number attached to them as well. So we can use less than, we can use greater than, we can use less than or equal to, or greater than or equal to. And then == sign means that we're testing for equality. So often in the beginning, you're so tempted from your understanding of maths to use == sign. In C, == sign is assigning a value, and == signs is testing for equality. So == signs, we test for equality, and then the exclamation mark and an equal sign, which says not equal to. So we can test for all sorts of things like that. Now, all of these will result in a 0 if the condition is false, and a 1 if it's true. Okay, what if I'm very, 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 very curious and I want to ask 2 questions at the same time? Who knows? I might. And that kind of can stop me from having too many chains of if, else, if I want to know what happens. So I can use and, or. So 2 ands give me the and expression. Okay, and is basically gives true if both of those conditions are true. So everything has to be true for it all to be true. And then or any one of the 2 expressions has to be true for it to be true. And of course, if you use an exclamation mark in front of the expression, then it means not. So it reverses whatever the expression was in there. Now, when you start programming, you'll notice that you will avoid using not at all costs, basically. I don't know why, but it seems to be the way everyone doesn't like to use not, because it doesn't make as much sense, I suppose, when you're first starting out what to do with not. So don't be scared of it. It just means no. Okay, I'm going to do one more quick Kahoot just to see if you understood those. And then we're going to continue, and we're going to write a piece of code. So I know, I'm just making up for no Kahoot last week. So after this Kahoot, we're going to do a program where we're going to actually use an if, and then we'll use an else, and then so on and so forth, and we'll do it with characters as well, just for fun. Okay, someone online. Yep, thank you. Did you? Okay. Yeah, don't use switch statements in 1511. Thank you. All right, let's get the party started. Oh, very nice. I like that 4 people did choose to make our lives more difficult. Thank you. Very nice. You sacrificed that answer so that you could choose that. Will this statement give true or false? So remember, the 2 dashes means or. Why is it taking so long? I put a really long time on this, just in case you really need to think about it. And then I think I put 20 seconds on the harder numbers ones. Ooh, split evenly. Okay, so in an or, either one of those statements has to be true for it all to be true, right? And there's 2 things here. There are 4 penguins, which is true. That means I don't even care what the second statement is. My whole thing is going to be true, okay? Here we go. All right, what happens in this one? Oh, everyone got that one. So both of the statements have to be true for an and. There are 4 penguins is true, but they are not all the same height, which means that the whole thing is false. All right, let's try it with, still on top. Let's try it with numbers. True or false? In case you've got issues with less than or greater than, think of the alligator eating the bigger number. All right. So in here, 7 is less than 15. That's true. But 8 is not greater than or equal to 15, which means that the whole expression is false. Oh, someone else coming? Ah, very good. Okay. So because it's an or, either one of the statements has to be true for the whole thing to be true. And 7 is less than 15, so I don't even check the second part because it's all true. All right, the dreaded not. So the not goes in front of the whole statement in this case. Oh. Okay. So first do the thing in the brackets. So is 5 less than 10? Yes it is, which means that this statement is true. But then when you go to the exclamation mark, it negates it to false. So the statement is false. All right, last one. What happens with the letters? True or false? Okay. So A is less than Z because A comes before Z. So the number for A is less than the number for Z. All right. Let's see who came on top. Adam, number 3. Oh, number 2 from number 1 in the first one. And number 1. Oh, Tim. Nice. Great job. All right, I think it's time to write some code. All right, let's go to our very first if logic. I've called it iflogic.c. And I've got 2 problems just in case we don't have enough after doing 1. Shh. I know it's super exciting, your first bit of if statement code. Okay, let the user provide you any number and you must determine if the number is even or odd. So how would we solve it? What do you think would be some steps in solving this problem? Okay, so here it says let the user provide you any number, which means I need to take some input in from the user. What will I use to get input in from the user? Scanf, excellent. Okay, so the first thing I do is I'm going to take the input in from the user by using scanf. Okay, great. So now I've taken the input, I'm going to need something else to do. I need to determine if that number is even or odd. And then I actually should extend this problem because what do I do after that? Let's say if even, print the and then if odd, print the number is odd. Okay, so how will I check if it's even? What do we think? You go front. Yeah, we'll take the modulus. Great. So to check even, we will take that number and modulus by 2. And if we do modulus 2, what will we check? Will we check that it's equal to 0? Yeah. So we will check that there is no remainders when we take a modulus of 2. Excellent. So if that is true, so if that statement above is true, then we will print out even. And what, oh, I've already written it down, printf, I'm way ahead of time. And if that is false, then we will print out odd. Okay, so we've got some basic steps. Now let's see if we can actually do it within our program. Okay, so what's the first thing that we need to do? We probably need to declare and initialize a variable that we will scan something into as well. So let's do that. Okay, so I'm going to have an int, and I'm going to call it number because it's going to be a number. So I've declared, oh my gosh, no, I didn't initialize it. I've just declared a variable number of type int. And now I'm going to initialize it by scanning into it. So taking the user input. Okay, so we said we're going to use scanf, and to use scanf, I'm taking in an int, which means that the format specifier is %d that I will use, and I want to put it into my number variable. So remember, I'll put an ampersand because it's saying to go to the address where that number is stored, and I'm going to store it into the variable number. So that means I've done number 1 over here. I've taken the input in from the user, and I have stored it inside this scanf. Someone online has asked a great question, and they've asked, why not LF? Because a decimal is later needed. Why would you need a decimal? Do you need a decimal? Do I need a decimal? I don't really need a decimal. All I'm checking is that there's no remainders when you divide it, not divide it, when you take modulus of it, which means you're dividing it by 2. Is there a remainder? No, there isn't. Okay, fantastic. So, what are we going to do? Now we're going to, okay, I think it's too early to talk about what's scan. We'll do this program first, then we'll talk about scanf. Okay, I'm going to check what happens and what the modulus is. Now we can do it in 2 steps. We can do it all in the condition, or we can do it, so we can check for that within the condition, or we can check for it outside the condition. Up to you. 2 more steps or 3 more steps. What we're doing in 1511 is usually not good style because we will take more steps to do something than is strictly required, but sometimes that's better for understanding. Maybe it's better to do it inside here for now. Okay, so I'm going to say if my number modulus 2, and that means if that whatever scanned in divided by 2 remainder. Now what do you think I'm going to use? 1 equal sign or 2 equal signs? Very good, because I'm checking whether it's equal to, not assigning. I will only use 1 equal sign if I'm assigning something. So what that's saying now, if that number modulus 2 is equal to 0, well then I'm going to printf that it's even. Okay. And now I want to have something else happen if it's odd, okay? Which means if that's false, so I can do an else here. And now I can just print out odd. Okay, that's pretty simple. That seems to be okay. How's everyone feeling? I hope everyone's feeling good. Don't worry, we can run through it as well, line by line as well in a second. I brought a drawing board, so you get to see me squiggle now as well. Okay, let's compile. And let's run it. Okay, it would have been nice to ask for input. It's sitting over here waiting for me to input a number. So let's do something that is going to give us even. Okay, amazing. And now let's try if it works for an odd number. So I'll do an odd number. Yep, that works as well. What else should I try if I'm trying these weird and wonderful things? Yep. A decimal, okay, let's try a decimal. What will happen if I try a decimal? Okay, why do you think it gave odd? Yeah. Exactly. It only took in that first int, the 3, and then it farewelled me and moved on with its life. Okay, also this is so ugly, I can't cope. Sorry, let me just add some new lines so that we have, and let me also ask for input here because it's impossible to... Okay. Now that's looking nicer. Okay, so that's... So now if we do 6, it says it's even. If we run it again and do an odd number, it'll say odd. Anything else that we want to try? Yeah? A character, why not? Yeah, that's going to break it nicely. And we'll talk about how we can fix that break. That's an excellent thing there. Yeah? Let's do a negative, okay. So we assume that a negative will work because it is an int. Yep. Okay, good. Anything else? Yeah. 0. Always a nice one to try. Okay. Even. Anything else? Yeah. A space. Yeah, space will just be a disaster because it will just keep waiting until you put in an int. Okay, so that's pretty good. I want to go back to, oh, it's 11:55. My goodness, how fun. I want to go back to where it gave me this runtime error and it kind of chucked a bit of a tantrum because I gave it a character. Okay, so I'm going to talk a little bit about scanf. I'm sorry this might take you over the edge. I hope not. But you've heard me mention the word function, you've heard me mention the word return, and something input. So I'm going a little bit ahead here. We're going to learn about functions next week. But for the sake of keeping it very basic, a function takes something in and outputs something, and maybe returns something, or maybe outputs something to a terminal. So scanf is a function that is used, that we use to take input from the terminal, and scanf returns something. Okay, it doesn't, right now we're pretending it doesn't return anything, we're just using it to put a number in, but it does return something, and using what it returns is a way for us to safeguard our programs from the errors that can occur if something that we didn't expect gets put into the program. Okay, so what scanf returns is it returns the number of things that were scanned in successfully. Okay, and I'll demonstrate that. Okay, so, and I'm going to write some little notes in the code. So scanf returns the number of things that were scanned in successfully. So I'm going to do this in like 3 lines of code just so that it's clearly set out whilst you're beginning. As we go on, we will move it all into 1 line and kind of all together. So scanf returns an int, the number of things that got returned successfully. So I'm going to have a variable and I'm going to call it scanf return. Okay. And what that will do is, so I will declare a variable to hold whatever it is that scanf returns. Now what I mean by what scanf returns is that the output of this running, this scanf %d and number, actually brings back a number to the program. Right now, I'm not storing that number. I don't care about it. I'm basically discarding it. It's going nowhere. But what I'm going to do is I'm actually going to find out what that number is by assigning whatever this returns, and in C the right side always gets performed first and then it gets assigned to the left side. So what this will do is it will go to the right side, it will perform this, it will come back to the program once the return is seen in scanf, and it will give a number. And that number is going to be assigned to this variable scanf return, okay? And just for the sake of clarity, let's see over here what that value is. Okay, now let's try and run it. Even better, let's clear the screen so you can see something. So I'll compile it again and I'll run it. Okay, we'll enter a number. Now we'll enter 8 and you can see that the value of scanf return is 1. And the reason for that is because it scanned in successfully one thing. It scanned in the number 8 and everything was successful. Now if I run it again and enter a character, what you will see before it quits and has a tantrum is that the value of scanf return is 0. And that's because it scanned in nothing successfully. Okay? So what I can do going forward, and we might do it after the break, is I can check that scanf has returned 1 and then I will proceed with something. And if not, I'm just going to exit the program because something is not working, or I might ask for input again. So it helps me to capture errors, right? Before tantrums are thrown and your program doesn't work as it should. Okay, let's have a 5-minute break because we've hit the 12 o'clock mark, and then we will come back in 5 minutes and we will keep going because then we're going to do an if statement with characters. Let's keep going. Okay, so who would like to actually, I'm sorry, just as you're eating, you knew it was coming. It's like a child when they see you sit down and they need something. I didn't need you to stand up. I really just, I wanted you to do a poll. And in the poll, ask if we should run through the code that we just wrote line by line, or if everyone's happy to move on to do characters. It's a real fight here. Yeah, I think the scanf return really killed the vibes. And it's a real even split here. This is making it impossible. Oh, now it's 50-50. Great. Am I being trolled now? Now I have to make a decision. I don't like making decisions. I'm going to run through it. Even though 51% are now on the move on camp, if the line by line camp increases by 1%, we will, here we go. I am being trolled now. Now it's just trying to get to the 50-50. I'm going to run through it briefly, line by line, so that you get to see what on earth. Oh, and then someone in the chat is saying, move on. It's, look, those of you that have programmed before, these first few weeks, you will be thinking, just move on already, right? But the 50% that have never programmed before are thinking, I really hate my life. What am I doing here? So let's be kind. And let's do it line by line quickly, and then can you eat during the lecture? Absolutely, as long as it's not something that I want as well. So good luck guessing what that is. All right, so I'm going to do it very quickly and run through it. Okay, so let's see what happens, and let's hope this pen is calibrated. That was also Sophia's job, so we've got someone to blame if it's not. So the first thing is first, it is not calibrated. I've got my first function and it is the main. Okay, so this is going to be really weird writing because the thing is not calibrated. It's not your fault. It's just blame the system. Okay, so I go on to line 27 over here and I say give me a variable called number. So I've just created a variable called number and it's got no values in it yet. This is not going to work very nicely. Then I say print enter a number, so that goes out to the terminal and it will print out enter number on terminal. So I'll do terminal here. Okay. Then on line 34, I'm now declaring another variable. So my next variable is going to be scanf return, and they're not initialized, which is a bit naughty. Okay, so now what happens on line 35? I'm going to move across to this side over here and I'm going to perform what on earth is happening. And let's pretend I've put in a number and I've not been, mean. Let's say I'm going to put in the number 3. So I'm going to scan in, take this 3 from the terminal and I'm going to place it inside number. So now over here, this is now going to have the value of 3. Okay, great. And this function over here, scanf return, has returned 1, okay, overall. And that is the variable, the number that's going to go into scanf return. So scanf return is now going to be equal to 1. Okay, now I'm going to print out the value of scanf. So I've printed out whatever that 1 is. And now I move to line 38, where I'm going to check. So number right now is 3, which means what I'm checking is this condition here. So is 3 modulus 2 equal to 0? The answer to that is false. Okay, since it is false, I am not going into the first portion of this code. And what I'm doing instead is that's going to be really annoying now because I've got to move the screen. I'm going to move into the else. Okay? And that means when I move into the else, because it's false, so false will go in here, and I'm going to print out odd on the terminal. And then we finish by going to, I think, return 0. Yeah. So return 0 over here, and it dies. And when I get to this point over here, this line 45, what happens is all of my variables are also killed. So that dies, and I no longer need any memory for them. So it does all the tidying up for me. I don't have to remember what I've created and what I'm doing. Okay, so that's that simple code. Let's try and do it with characters now. So let's go and once we do it with characters, we'll see how we can use that scanf return as well. And don't worry, you still have your tutorials this week, and you'll go over the stuff that we did last week in your tutorials. And we will be sort of kind of following as well to extend on what's going on. Okay, so let's do this file over here, lower. And in this file, what we want to do is we're going to use an if statement with letters. So a user inputs a letter. We must check if the letter is an upper or a lowercase letter, and then output the same letter, but in the opposite case. All right. How do we think we would go about solving this? Someone online is annoyed by this tiny little red dot. There you go. Hope that makes you feel better. I feel that too, very strongly. Okay, so what do you reckon we're going to do? We want to take input from the terminal. We want to read in a letter. Okay, so the first thing I suppose we should do is we should scan in a letter. And if we scan it in, we're going to use scanf. Okay, then what do we want to do? We must check if the letter is upper or lowercase. Okay, so we're going to check if it's upper or lowercase. How do you think I can do that? I keep no one on this side. I haven't, down the back there, haven't asked you anything. Yeah, you. Yeah. What will I do? Will I use... Yep, so I'm going to really just do a comparison. And I'm really assuming if it is between A and Z, it must be lowercase. And if it's between A and Z, then it must be uppercase. Okay, great. And the way I'm going to check for that is I'm actually going to use my relational operators. So you will be tempted kind of from maths. Let's say the character is, to basically do something like this. And it is so tempting to do that. If the character is between A and Z, you can't do it in C, unfortunately. You have to kind of break it up and use some conditional logic as well with it. Sorry to say. So you just have to do a few extra steps. And the way you would do it is you would say, okay, let's say the thing is called character. So I want my character to be greater than A. And what do you reckon comes next? And or? And, yeah. Because I want both conditions to be true. I want it to be greater than A and less than Z. I kept wanting to say 0, I don't know why. And then I also want my character to be less than Z. Okay, and that will allow me to check whether or not it's a lowercase letter. And then similarly, for an uppercase, I would check that the character is greater than a capital A and less than a capital Z. Okay, and the reason I'm doing that is, for those of you that don't remember, I'm basically checking that it lies between little a and little z, somewhere in between there. And I don't have to remember the numbers, the ASCII numbers, because by putting it in those single quotation marks, I'm letting it know that it's an ASCII value. So I can do it a lot more in a more readable way, because I can just say A and Z. I don't need to kind of do a song and dance about it. Okay. And now comes the hard part. So fantastic, we've checked what's going on, but now if it's a lower, then I want to convert it to an upper. And if upper, then I want to convert it to a lower letter. Okay, now that's going to be a little bit trickier, but we can have a look at how to do it in a second. Or should we? Let's just write the first portion of the code, and then we'll look at how to do the actual conversion. Okay, so beautiful. We don't have anything going on here. So the first things first is we're going to scan in a letter. Okay, so let's scan in a letter. So first thing we want to do is we actually want to declare So declare a variable of type char to scan in a letter into. So it's going to be of type char, and I'm going to call it character. So I've declared a variable, and now it's time to initialize it by scanning into it. Okay, I'm going to prompt for it this time to make it look nicer. So I'm going to ask for the character, and then I'm going to take a character off. So I'm going to use a %C format specifier, and I'm going to place it inside character. Okay, who remembers what can go wrong here with this %C and what we can do to kind of combat it? Yeah. Perfect. So we want to put a space here before the %C so as to tell scanf to ignore all the white space that comes before it. So it's not just going to be continually hanging. Yeah. Oh, it's a lovely question. So the person has asked if we can use getChar. You can hypothetically use getChar if you're taking in one character. For those that don't know, getChar is a character, is a function, and we're going to kind of look at it a little bit in the further lectures when we do the libraries. Yeah. Oh, I mean, you can, yes. And we do it later on, but then we don't do it anymore because I've decided I'm sick of getChar when we have this. But in programming, there's no one right way to do things, right? There's multiple ways to solve a problem. And contrary to what is believed, programming is actually a very creative thing to do, because you can do amazing things and you can solve things in a pretty creative manner as well. Okay, so now we've scanned in the character, and now we want to do something. What was the next thing that we're going to do? We're going to check if it's an upper or lowercase, and we've kind of got our code for it. So what I'm going to do is I'm going to have an if statement, and the condition is really going to check whether that character is a lowercase or an uppercase. Okay, so just to check that the first bits are working, I'm going to just do that, which will just allow us to see that everything is working, okay? So I'm saying if it's between A and Z, that must mean it's lowercase, else I'm going to assume it's an uppercase. Not particularly, we'll see what can go wrong with just assumptions. Okay. So let's see if this first bit works to start with, and then we can do work on our conversion. Okay, so I'm going to clear it, and I'm going to compile it, and I'm going to run it, and let's try character. So we've got a little t, lowercase, that's working. I'll try capital letter, that's working as well. What are some good things that I want to try always when I'm testing my code? Actually, this is a great one to do it with. Come on, 50% of you said to move on. I know you know the answer to this question. I can't hear anything. There's too many people. What? I'm sorry, I can't hear you. Sorry, there's too many people speaking. Go on, say it again. Debugging. Okay, but what can I, just playing around with input, what input would I put in myself to see if I can break it or not break it? What do I test with? Yeah. Yeah. Okay, perfect. I want to look at edge cases. So boundary conditions. What are my boundary conditions in this piece of code? Yeah. Yeah, so that's, and then what would be my edge case? So what would be my boundary conditions as well if I'm testing that the characters between A and Z? What are the two things? Yeah, I want to try A and Z. I want to try something in between, and then, as the lovely gentleman said, something that is outside of this range as well. So another ASCII character, any of the slashes or enters or anything else that comes in there. So when I run it, what I'm going to do is I'm going to try it for a capital A. It's working. I'll try it for a capital Z. It's working. I'll try it for a little a. Yes, and I'll try it for a little z. That's working. Then I'll try something in the middle for fun. That's working. And then what happens if we try something that's random? I don't know, number 9. It's uppercase. Fantastic. Why is it doing that? Yeah.
It's not between A and Z lowercase.
Exactly. So it's doing that. It's saying it's uppercase because all I've said is if it's between A and Z lowercase, then print out lowercase. Otherwise, I'm going to assume that everything else is uppercase. Okay. So now I have something where I haven't considered that someone is going to break my code. So I really want to fix this a little bit. And I actually want to have something that checks if it's an uppercase. So I'm going to have an else if here, and my condition is going to be checking that it's an uppercase. Okay, so then it's going to be an uppercase, otherwise, and that's when I don't really care what it is, and I can say you didn't enter . Okay, so now that's going to capture some of those edges as well. So it's going to make sure that we're only kind of having a letter that's going through. Okay, so now what I need to do is I need to really convert it from a lowercase to an uppercase, and then I need to go the opposite way as well. So if it's a lowercase over here, I need to convert it to an uppercase. Now let's have a look how we can do it. Always helpful to look at this. Okay, so it's really much easier to go with the, anyway, we'll go with the little letters first. Let's say I've entered little a. Okay, so let's say my input is the little a, which is 97. Okay, that means I want it to become a capital A, which is 65. How do you think I will move between the letters? Yeah.
When you're doing your printf statement where you say it's lowercase or it's uppercase, you can add in the character, and when you're assigned a percentage seeking, and when you're assigning that value after the comma, you just plus minus 32 depending on whether it's upper or lowercase.
Yeah, absolutely. So because of these random bits here, there's 92, 93, 94, 95, 96, which kills the vibe. It's not a perfect 26 because there's 26 letters in the English alphabet. But the difference is 32 between the lower and the uppercase letters. Yeah. So I can say to subtract or to minus 32, which will get me to wherever I want to go. Very nice. Okay. Now, if someone else was reading my code and, you know, they maybe don't know the ASCII characters that well, will the 32 make sense to them? What can I do? What else can I do? Yeah.
You can replace 32 with small a minus capital A.
I can do that, absolutely. So what I'm doing is, and this is like, for those, don't worry, you will get very used to doing this and playing with characters. Let's say I've got the letter C. Now the wonderful thing about the English alphabet and most other alphabets really is that your lowercase letters are the same distance away from each other as the uppercase letters, right? They don't shift in the alphabet just because they're upper or lowercase. That always remains consistent. So if I'm in the lower alphabet, so lowercase letter, and let's say I've got C, what I can find out is I can find out how many letters in is this letter, okay? So if I'm at C and I subtract A, the first letter of the alphabet, I'll know that I'm 2 characters away from, you know, from the top of the alphabet, okay? So I'm the second character. And then I just add it to wherever I need to go from to get the same distance from my capital alphabet. How's everyone going? Has everyone just died of that? Brain exploded for those. Sophia, are you polling? Thank you. Have you finished your yogurt? Was it good? Excellent. Okay, so let's try it a few different ways then. Okay. So I'm going to comment out this, and instead, actually I'm not. I'm just going to say it's lowercase. So it's lowercase, and I'm going to say here the new letter is. Okay. Now, I don't know if it's confusing to write it in there or if it's okay. I could just change my character. So I could do my maths in here. So my new character is going to be, so if it's between A and Z, then what we said, I'm going to take my character, I'm going to subtract, and if it's a lowercase letter, I'm going to subtract little a, because that will tell me how far away I am from the start of the alphabet. And then I'm going to add it to the capital A to move the same distance in the capital letters alphabet, okay? So what will happen is it will go on the right side, it will perform this situation here, and it will assign the new character on the right-hand side, okay? It will assign the new letter to it, and then I'm going to print it out here. Okay, and if we do the same thing for the uppercase letters, what we can say here is that the character is equal to, I'm going to take my character that was put in, and if I'm in the capital letters, then what I'm going to do is I'm going to subtract a capital A to tell me how far this letter is from the start of the alphabet, and then I'm going to add a little a to move the same distance in the lowercase alphabet. Okay, and then over here I'm going to okay. Is that thunder or someone moving furniture? Okay, so let's compile it again. And let's run it. All right, first character, little a. New letter is capital A, yay. Let's do away, yay. What else can I do? Anyone? Let's do a number. It'll catch it now. You did not enter a letter, and it will exit me out of it. What else should I do? Yeah. Okay, that's not going to be a nice one to do. I can do enter. It's not going to do much there. And that's because of we're not capturing mistakes yet from scanf. Yep. Let's do like a capital, yep. Okay, so it's working both ways, yep.
Something non-ASCII.
Something non-ASCII. I mean, it should really kind of go over there when you did not enter a letter. It should capture it, or the scanf should break because it's actually because we're scanning in a character, so it will. So we really maybe want to do the scanf return again. Yeah. To capture some. Oh, good, Sophia. Thank you. Oh, people are going great. You entered the poll and it just kind of jumped as I was. Okay, someone said, couldn't we use number instead of letter to move from upper to lower? And the reason we don't do that is because it becomes very unreadable in your code. Okay. Okay, very good. Okay, how we... Oh, you've already done the how we feeling. Okay. Let's do the scanf in that case. Okay, so let's see what scanf captures here. So I'm going to do so I'm going to declare something to capture my scanf output. And I'm going to call it scanf return. And then over here when I'm scanning in, what I'm going to do is I'm also going to assign whatever this returns into that variable. Okay, so then to stop all of this rubbish happening when we get this situation where it's just not doing anything because scanf is just not working, what I can do is I can check that scanf returned 1 and I do my program or run the rest of it only and only if scanf has returned 1, which means that something was scanned in successfully. Okay, so I'm going to do an if statement and I'm going to check that scanf return is equal to 1. So if scanf return is equal to 1, then I'm going to do the rest of this stuff. Okay, so what happens now is that this program will only run if we've scanned something in successfully. And if it hasn't been scanned in successfully, then it will just not go into any of the if statements. Because remember, the if statement is only gone into if the return of the condition is true. So if this is false, then it will go all the way down to the bottom, it will return 0 and it will exit. And that will capture some of those errors. And I think it's the easiest to see if we run it again. And then, Sophia, can you poll if people want me to run through the line by line with an uncalibrated pen? No, it's not your fault. It's this tablet. Okay, so let's enter a character. Okay, so that's because that's on the ASCII table, and I really should have just put it. Oh. Also an ASCII character. Okay, so what can I do? Okay, that's capturing it as well. Any other character that anyone thinks that will break it? Yeah. Yeah, I hate creating that because yep. It will cancel because it's not. So basically anything that's not on this table it will not, it will exit out of it. Okay, quite a few people want to go through it line by line. Okay, sorry to those that don't want to do that. But you've been beaten by this. Okay, so let's go through it line by line. Just going to move the terminal down a little bit so that there's as much space as possible here. Someone's asked if we can use two lower and two upper functions. Not right now, no. You'll be able to later on. Okay, so let's do it. So we go into the main on line 24. Okay, nope. We head into our main function and it's not really writing now at all. How exciting. Okay, so the first on line 27 is we declare our first variable, character. It's got nothing assigned to it yet. Okay, then we go on line 29 and we print out enter a character, so that goes out to terminal. Then on line 31 I declare another variable called scanf return, so that means I've created another variable here. Amazing. And then I go on line 32, I'll move to the right side and I'll scan in a character. Let's pretend that I'm scanning in A. So I'm going to scan in this character and I'm going to place it into my character, which means this is now going to get an A to it. So the A is going to go in here. And this whole function is going to return 1 because I've just scanned in a successful A. Yeah. The and before the character, it means go to the address of. You will learn more about it in week 5. It's basically asking for a memory location of wherever that variable is stored. If you do scanf, you have to put it every time because that's what the function inputs are. Okay, so then into scanf return is number 1, so I'm going to assign a 1 in there. And then I'm going to go to line 34. And in line 34, I'm going to check the condition scanf return. I'll have a look what my variable is. It's 1, which means I'm checking is 1 equals to 1. That is true, which means I'm going to go into the curly brackets. So that means I'm going to move into my next block of code. Now I'm going to check what the character is. So the character is equal to A, which means here I'm checking is A greater than or equal to A, and is A less than or equal to Z. So this is true over here, and this is true over here, which means that this whole statement is true, which means I go into this block of code now. And so now I go in here. Remember, I go to the right side first, and what I do is I take my character, which is A, and A is 97. So this character here, A minus A, okay, that's going to give me 0. And then I'm going to add the 0 to a capital A, which is just going to give me a capital A. So if you do it in numbers, what happens is I've got 97 minus 97, which is 0, plus a 65, which is 65, which is the capital A. So what this is going to output for me is a capital A. And it's going to get assigned to this character. So this is now going to be a capital A. So it's been reassigned a different value. I hope you can see that I've crossed this one out. There we go, I've crossed it out. And now I'm going to print it out. So print out, it's lowercase, the new letter is %C, and I've called this character. The character is big A, which means that this thing here is going to print out a big A. Okay? Now, if my character was a capital T, for example, then what would have happened is is I would have scanned it in. It would have still the scanf return. It would have scanned in one thing successfully. My character would have been a capital T. And I would have gone onto line 34. I would have checked if 1 is equal to 1. Yes, it is. It's true, which means I would have entered the block of code as well. I would have gone to line 35 and I would have checked, is capital T greater than little a? Well, that's false, which means that this whole thing is false. Which means that I'm now going to skip this block of code and try my luck on the next one. Okay? And I'll do my next condition. I'll check it here. Is my capital T greater than or equal to capital A? Yes, it is. And then I'll check the next lot. Is my capital T less than or equal to Z? Yes, it is, which means that this whole statement is true. And it means that I'm going into this block of code over here. So for this block of code, I'll go to the right side and perform the operation before assigning it. So my character is capital T, which means I'll have capital T minus a capital A. And it will give me the distance that T is from A. And I can't remember what number is T. What's the number of T? Yeah, on the ASCII table. Uppercase? Okay, so it's 84 minus 65, which gives me the distance T is from the capital A. And then I'm going to add the little a, and the little a is 97, so I'm going to move the same distance from little a, which will bring me to a little t. So the answer to this is going to be little t, and then I'm going to go and assign that little t into my character here, which means that this t is now gone, and I've reassigned this variable with a little t. And then there's a printf statement underneath that. So that all works out nicely. Okay, how do we feel about that? Thank you. Anyone else? Sophia, sorry. It's so much fun just watching you. Sorry. I feel like I'm giving you anxiety every lecture. And it's because you're sitting the closest to me. Next time you should sit between, yeah. Leave Gab, yeah. I'll give Gab anxiety. Okay. Any questions so far? Yeah. This one over here on line 34? Okay. So this scanf function, what it does is it returns a value of how many things were scanned in correctly. And what it's checking is basically that someone entered something that is on the ASCII table, which means you can do something, as opposed to just exiting out. So if a character was given over here, and a character was scanned in successfully, it will return 1 for one character being scanned in successfully. So that's what this is doing, is just checking that I've scanned in a character and I can actually do some checking afterwards. Yeah. So, good question. As you move on, you will incorporate that scanf statement into whatever on earth you're doing. I'm not going to have a scanf return variable at all. I don't want an extra variable. You'll just check for it before you do anything, because you can use it as your condition. So I'm going to be really extra these next few weeks. Yeah.
I did the scanf, and after that, when I put a character instead,
What did you input?
and then it went to the else page.
Oh. Who would like to go up there and have a look? Okay. Gab does not feel like walking up the stairs. So please post on the forum, because it must be something in your code. And share with other students the love. That's right. Any other questions? I'm worried about doing a loop now because there's only like 7 minutes left. What? I could just start a little bit of loop so you can think about it for Wednesday. Okay? So in this current case, okay, when I run my program, if lower, all I can do is I can just ask for it once, and then it'll run through the code once, and then it will just stop. Which can get a little bit annoying if I want to repeat something in my code, and if I want to kind of keep going a little bit more, and if I don't want the magic to finish, I want to keep going asking things. What is even this? What is this white thing on my... Okay, so when we want to repeat things, or when we want to keep things going, when we want to keep asking for input, someone is just crying on there because I've missed a lot of dots. I'm sorry. You just... Yeah. A lot of very particular people in the course this term. All the dots are gone. Lucky for you, you can't see my desktop, or you would have a heart attack. Okay, so sometimes we want to be able to loop around, loop-de-loop, repeat the same thing or a similar thing many, many times until something happens that will make us stop. Okay, so like whilst there's songs in my playlist, I want to keep playing them. When there's, whilst there's red dots on the screen, I want to keep erasing them and not stop. So you want to kind of be able to keep going in some cases. And I think I actually just put a red dot on the screen by accident, so sorry. So usually what C does, and what you've noticed, is I will run through the code line by line. Shh. It's not long left, I promise. I know there's a lot of heavy content to start with. So what happens is that once you're past line 3, I'm not coming back to it unless it's inside a loop, okay? So C executes instructions in order, and it just kind of goes line by line in chronological order. The if statements allow us to turn on and off some pieces of code, so I can skip a block of code if something is not true, or if something is true, then I can go into that block of code. But there's no way to repeat code. For that lower case letters, I could just write the same code over and over, but that probably is not feasible, nor is it very pretty, okay? It's not very readable. Let's say, for example, why don't I finish on an infinite loop? Yeah, all right. And then, because I think everyone's brains are done. Okay, I'm just going to just forget all of this for now. I'm just going to use this file because it's already made, and I'm going to execute an infinite loop, okay? And I'm going to say what is the beautiful syntax for a while. So while some sort of condition is true, it means keep going, okay? Keep doing whatever is inside this block of code. So keep doing whatever is in here whilst this is true. Now when this condition becomes false, I'm going to break out of it. So when I break out of a while loop, this means that that condition is now false, and that's why I was allowed to break out of it. Now sometimes you can create a loop where it never ends, an infinite loop. It happens all the time. You'll have lots of places in your code where you'll have a good time with it. Can someone give me a condition that is always true? 1 equals 1. Oh, true. That's right. I'm going to go with 1 equals 1. Okay, that's never going to be false, is it? I'm never going to be able to exit out of this loop. I'm going to be stuck in it forever. And it's going to be magical. So let's see it in action. All right, I'm going to clear the screen. What a way to finish. I'll compile it. Bit of an anticlimax because I forgot a semicolon, so let's do that again. All right, and let's run it. Beautiful. I keep giving you some amazing things here. Okay, let's. How fantastic. It's because I pressed cut instead of save. Okay, let's compile it again. This time I swear it's going to work. Okay, there we go. And it's going to keep going and keep going and keep going, and I will never come out of this loop. It will break at some point, or I can break out of it as well. Who knows how to break out when you've created by accident an infinite loop in your code? Yeah. Control C. That's right. If you press Control C, you'll be able to come out of it. Otherwise, I've seen people close down their whole computer because they're like, oh, I don't know what to do. Control C is your friend. All right, have a great Monday, Tuesday. I'll see you all on Wednesday afternoon. Yay.